All right, we're looking at the binomial theorem today, and we're going to do some problems involving this. So we're going to start off by looking at what we call Pascal's triangle. Pascal's triangle is credited to Blaise Pascal, a French mathematician, although there is evidence of this triangle being used in Islamic texts and Chinese texts long before Blaise Pascal discovered it. He discovered it as well, and carries its name. With this triangle, we put a 1 in the outside columns of each row, noticing every row has one greater element in it than the previous row. Put in a 1 all the way down the outsides. And then the other cells in this set are made by an addition of the 2 above it. So this cell here is going to be given by 1 plus 2, so we're going to get a 3 here. This cell here is going to be a 3. Here we're going to get 1 plus 3, so we're going to get 4. 3 plus 3 gives 6. This one's going to be a 4. What's row 5 going to be? What's row 5 going to be?
5.
Let's see some hands. Let's see some hands. Even?
5, 10, 10, 5.
5, 10, 10, 5. Row 6. Danny?
6, 15, 15, 16.
What's 10 plus 10?
20, 15, 6.
15, 6. So this is, we can generate this, and using a recursive definition, you can start at 1 and make it all the way down to wherever you want to keep going to. We'll use this a little bit. Let's see where it relates. So we're going to start off by expanding these binomials. So a plus b to the power of 0, what's that going to be?
1.
That's going to be 1. A plus b to the power of 1. So that's going to be a plus b. A plus b squared.
A squared plus 2ab.
A squared plus 2ab plus b squared. So we've got 1, 2, 1. What about a plus b cubed?
A cubed plus 2b, 3a squared. 3a squared, b squared, something like that. Something like that. B squared. 3ab squared plus 3b plus b cubed.
No, 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 not again.
Oh my goodness.
Attention, please.
All right. So what's the next row going to be? Well, look at the red numbers. We've got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. For Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. What's the next row of Pascal's triangle?
4, 6, 4, 1.
So this is going to be 1, 4, 6, 4, 1. What are the terms going to be? Well, this is to the power of 4. So this is going to be a to the 4. This is a to the 3, b to the 1, a to the 2, b to the 2. This one's going to be a, b to the 3. This is going to be b to the 4. And then we need the sum of each of these. How many terms are there in expansion of a plus b to the n?
N plus 1.
Why is it n plus 1?
Because Pascal starts at 0. It starts at the 0th level.
So the first row starts at 0, the second row starts at 1, and there's 2 terms. The next row is 2, and there's 3 terms. The next row is 3, and there's 4 terms. So there are n plus 1 terms. This one's important. This is usually where you go wrong. It's forgetting that basic idea.
So what's the name of this? It's just is it like
Pascal's triangle.
Oh yeah.
Without expanding, what is the middle term in a plus b to the 6?
A to the power of 8.
Hold on, don't think out aloud. So here's row 6. What's the middle coefficient? 20. What's the middle term when we're to the 4?
6.
A squared, b squared.
So it's half.
So what's this one going to be?
28 to the 3, b to the 3.
20 a to the 3,
What if it's like
E
to the power of 5? What would it be then? Oh, that would be to the 3 to the.
Wouldn't have a middle
There's no
term.
middle. So then.
There's no middle
Then
term.
it's like.
There's no middle term.
Oh yeah, what is the middle term?
Different question. You get a different question. All right. So we're going to use Pascal's triangle to find the one. Let me show you the first one. So what we want to do is we're going to do to the power of 3. So we go look at the third row of this one, and we get 1, 3, 3, 1. We come back here. So what we're going to want is we're going to want 1x to the 3, 5 to the 0, plus 3x to the 2, 5 to the 1, plus 3x to the 1, 5 to the 2, plus 1x to the 0, 5 to the 3. Notice the exponents: 3, 2, 1, 0, 0, 1, 2, 3. You take the whole term. You take the whole term that is in this location here. So you look at what's here, you look at what's here. So we're going to take, when you guys do that one, you're going to take 2x, and you're going to take minus 1 to do that. Let's expand it now. This one's going to give us x cubed. Here we've got 3 times 5, so plus 15x squared. Here we've got 5 squared, which is 25. 3 lots of that is 75x. And this last one is going to give us 125. Have a go now at doing an expansion using Pascal's triangle for the lovely expression 2x minus 1 cubed. Let's go. I will pause the video in case we do manage to finish this in half the time that Blockade managed to do it. Some people are. Okay, let's have a look. 2 steps. So our first step is what are the coefficients? We've got 1, 3, 3, 1. It's cubed. Next up we have 2x to the 3. We have minus 1 to the 0. Here we're going to get 2x squared minus 1 to the 1. 2x to the 1 minus 1 to the 2. And then 2x to the 0 minus 1 to the 3. Expanding our coefficients, so minus 1 to the 0, what is that? 1. 2x to the power of 3, 8x cubed. Our next one, minus 1 to the 1, so this is going to become negative. 2x squared, that's 4x times 3, 12x squared. Minus 1 squared, positive. 2x to the 1 is 2x, so we get 6x. Minus 1 cubed, minus 1, so we're going to have minus 1.
So 8. Oh.
Take care with your signs.
Wait, because the 2x is also cubed.
Okay, so let's look at these numbers. Look at the numbers 1, 3, 3, 1, the ones we're getting from Pascal's triangle. We need to name them. So we can name them using combination numbers. So 0C0 is the first one. So in row 0, we only have this one. In row 1, we have 1C0 and 1C1. In row 2, we have 2C0 and 2C1 and 2C2. In row 3, we have 3C0, 3C1, 3C2, 3C3. What are the names of the combination numbers in row n? Have a go writing this out.
How many?
No.
What was the question again?
What is the name? List the combination numbers in row n.
So C and
List them on your paper, not with your mouth. I'm sitting down.
No, it's N.
then all the way.
Need a minute.
Then all the way. It's C. C plus N plus 1. So C and It goes all the way to n, c, n plus 1. No, plus 1. It's not n plus 1. Look, in the third row, there's 3. In the second row, there's 2. In the first row, there's 1.
How is that?
Jonathan's right. Listen to him.
Yeah, so look, and you look at row 3. Yeah, look at 3. Look at row 3. It's the same. It's the same. So it's just yeah, there's in every row. In every row, there's the same. There's n plus 1 number, but since it starts at 0, so it's the same size.
Okay, let's have a look at the answer here. So, row n. What is the first term in row n?
n0.
N, C, 0. I write them like this. There's two notations for it, with the n raised in superscript or subscript. Next term, n, C, 1. Then dot, 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 n, C, n minus 1. N, C, N. So here is our pattern. Let's see how we can calculate them. So we have a formula for it, NCR. We're going to start off by looking at the factorial function. Here's n factorial, here's 7 factorial. So look at the function. So 7 factorial is 7 times 6 times 5 times 4. What would 4 factorial be?
4 times 3 times 2 times 1.
What would that be?
No, yeah, 24.
Okay. I'm going to show you how to calculate 5C3 using this formula here. So we need n factorial. What's the value of n? What's the value of r? So we need 5 factorial, we need 3 factorial, and we need 2 factorial. Notice the two numbers in the bottom, always 3 and 2, always add up to be 5, to be the other number. You can prove that pretty easy. Look here in our formula. We've got r plus n minus r, which is r plus n minus r, which is n. That's why they add up like that. We can expand this into being 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. We can expand it like that.
Doesn't like half the stuff cancel out?
Yeah. So, don't have to expand it the whole way like that. I can expand this. What do we have to multiply 5 times 4 by in order to get 5 factorial?
3, 6.
We need to multiply it by 3 factorial.
Oh, and 5 times 4 factorial is also.
Here we've got 3 factorial, and here we have 2. I mean 2, not 2 factorial, they're the same thing. So the 3 factorials can cancel. So this can cancel with this 2 can cancel with that 2. How much are we left with? 10. Have a go at calculating 12C10 for yourself.
Every single number before.
Okay, let's have a look at an answer to this one. This is 12 factorial, 10 factorial, 2 factorial. That's going to be 12 times 11 times 10 factorial over 10 factorial times 2. That cancels, this halves this one. And we are going to left with 6 times 11, 66. This is how we can calculate combination numbers. Let's do it now. Take out your calculators. We're going to show you how to do this on your calculator. Take out your calculators.
By the way, can you turn off that screen? Yeah. Mine's not that.
Did that more than a house.
Maybe just try to yell a little louder. Maybe it doesn't.
Right ones.
Maybe it has like false ads. Calculator.
All right, let's have a look at the idea on the calculator. Firstly, how do you calculate a factorial? So we press menu probability factorial, and we get a factorial there. Let's try the one we did. We did 4 factorial, menu 4, menu probability factorial, enter 24. That one's correct. Let's try the combination numbers, 5C3. So we press menu, we've got probability, we've got combination numbers, number 3. The syntax is a little different. We put in NCR 5, 3. 10. Let's verify that last one. Menu 5, 3. We've got 12, 10. 66. This is how we do them on the calculator.
Comma means divided. The comma is divided. Right.
It's not divided. This is a function. It's a program. So it has the brackets are parameter passing in coding system. So when it passes that code to this program, it takes 5 and then right place and we get the right variables. Does the right Yeah, that's the beautiful syntax. All right, let's move on to the next bit. So here we have the binomial theorem. So what we're looking at with the expansion with Pascal's triangle, we want to be able to go straight to, instead of doing recursively going all the way down from 1 to position number 20, row 21, we can get straight in at any particular term using binomial theorem. Binomial theorem looks like this. It looks really complicated. It's not as complicated as it looks. The general term is this one here in the middle. The rest of it is just to show how the expansion is created. So our first one is NC0, a to the n. If you go back to some of our expansions, the first term here is 1 to the a to the 3. So this is a to the n. So this is just how you create the first term. It's showing that the terms go, how the numbers change. So C goes up by, this is the R value, here is the 0. It goes 0, 1, 2, 3, 4, till n minus 1 at this point, and then up to n. So we see how the R number increases across the bottom. You see on the top how the other numbers decrease. So here we've got a plus x instead of a plus b. So we've got a to the n minus 1, a to the n minus 2, a to the n minus r, until you get all the way to the end where it's a to the 0 and it disappears. You see how the other term generates. It doesn't appear in the first one. We get this x to the 0, x to the 1, x to the 2, x to the r, up until x to the n. And it's just showing the progression. It's only this bit that we need to look at. What's changing in this formula is the n stays the same, a stays the same, x stays the same. The only thing changing is the r. The r starts off here at 0, 1, 2, until the r gets to n. So r is going to be always the numbers 0, 1, 2, dot, 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 n minus 1, n. So the r is always going to start off at 0 and go up to n. That's the only thing that changed. So we can summarize this whole formula here by just taking the general term here, which is this term here, and then using the summation symbol. the summation symbol iterates the variable r. It starts it off at 0, then it goes 1, 2, 3 until it gets to this number at the top, which is n, and then the formula adds the plus signs in between all of the different terms. It's a summation. So this is a great way of expressing the binomial theorem, very compact. Let's have a go at using it a little bit. Find the fourth term in the expanded form of x minus 1 to the r. I shall do this one for you. We'll do this one together. Then I've got one for you guys to do on your own. So, what is the value of n? N equals 8. What is the value of r? No.
0.
No.
1 to 4.
No.
1 to 7. 1 to 8.
Ooh, the A block got this quicker. No.
1 to 7.
No.
0.
No. Which term do we want? The fourth term.
So it's 4. 5. No, it's 4. It's 4 for 40.
Which is the fourth term here?
3. 0 to 3. N minus 1.
In the first term, what is the value of r?
0.
In the second term, what is the value of r?
1.
In the third term, what is the value of r?
2.
In the fourth term, what is the value of r?
N minus 1. What? N minus 1. It's just, this is for the fourth term in anything. It's gonna be 3. Okay. Because the fourth term is the fourth term on lecture is also going to be 3. So it's 3. 1 C 1 3. No.
The hardest part, well, this is an easy question, and it is actually quite easy here. But the hardest part of when we do a problem-solving question with this is figuring out what the r is going to be. That is always very difficult. After that, it's just mechanics and easy. And the hardest part, the problem-solving part, is what is the value of r? So, last chance. What is the value of r?
3.
3.
Is it always?
One less than the term.
The fourth term is always 3.
The first term, in the first term, r is 0. So r is always 1 less than what term it is that we're counting. So in the fourth term, r is 3.
Why? Because it is
So
random.
it's the term minus 1. It's the term minus 1.
It's in the question.
That's really not.
Okay. So the fourth term is going to be 8C3. Let me write up the general form. So we've got NCR, we've got A to the N minus R, we've got B to the R. This is the general formula for the binomial expansion. So we've got 8C3. We've got, what's A?
A is
X. What's N minus R?
X minus 2 is 5.
What is the value of B?
Minus 1. Minus 1 to the power.
Okay. Let's start off by finding 8C3 first. Have a go at this for yourself. What is 8C3? Do it by hand. Okay, let's have a look. So we need 8 factorial, so 8 factorial, 3 factorial, 5 factorial. So we need 8 times 7 times 6 times 5 factorial over 5 factorial times 3 times 2 times. So we can cancel the 5s here. 2 times 3 is 6, that cancels that. 8 times 7? 56. So we need 56 here. And then we need x to the 5. What is minus 1 to the 3? So minus 56x to the 5.
Because that's so AC3 it's a to the power of n minus r. Then it's just so any variable is 08 minus and then it's
Okay. Have a go at this one for yourselves.
Equal to minus no, it's 3 times 4 times 3 times 2. Yeah, what's 9 times 7? What's that? No, you don't. What's 18 times 7? I think what's the 18 times 7? I got the Oh, I did that over 4. And then I answered this side. So 18 times 106. Six terms. Oh yes, yes. Then you do it's A to the A to the N. Then it's B, so N minus R. A N minus R. A then B5. And then negative 1. Oh, that's nice. Yeah. That's just the area that's just actual triangle. That's just where we did. Wait, sir, I thought you did the factorial.
Got it, maybe 2016.
That's other more. This is just the value of this. No. So what was the point of this part? This is to find the term. This is to find the term. This is to find the term. Why do you use this?
This
is just to find what the value of this is. That's just
is the new unit. So this will be in the next step. We have a calculator.
That's the term.
Actually, I don't know. We'll see.
So we just use one on PDF and then the next one.
Unless you need to understand the concept, I can ask you a question that won't help. All right, let's have a look. So, what is the value of n? What is the value of r? What is the value of a? What is the value of b? So we are going to have 9c5. We're going to have 2x to the 4. We're going to have minus 1 to the 5. Let's find 9c5 separately. We've got 9 factors. 9, 8, 7, 6, 5 factorial. 4, 3, 2, 5 factorial. 2 times 3 is 6. We can cancel this 4 and put a 2 here. What's 9 times 7? 63 times 2? So this is going to be, might need to do a couple of steps. We've got 126 times 2 to the 4?
16.
Times minus 1. We can use our calculator for 16 times 126. Negative 2016 x to the 4. Okay. Multiple choice. So here on this part of the thing, I'd like the AP stats guys not to get involved in the classroom discussion because you already know the answers to this type of stuff. And I'd like to build the understanding of the concept for the people who don't do AP stats. So we have multiple choice quiz which has 6 questions, of which 4 equally likely options A, B, C, D to choose from. If answers are guessed and if X represents the number of correct answers, find the probability of getting 2 correct. But how do we do this problem? What is the probability of getting 1 question right? 1/4. The probability of getting 1 question right out of 1, 1/4. What's the probability of getting the next question right? 1/4. What's the probability of getting the next question? What's the probability of getting any question wrong? How do we get the 3?
3 remaining options. 3 wrong options.
What's the probability of getting another one wrong?
Again,
And then another one wrong? And then another one wrong. We can simplify this to 1 over 4 squared times 3 over 4 to the power of 4. Is this the probability of getting 2 right and 4 wrong?
Yes.
Oh wait, no, because that's assuming it's
No,
that's
that's it.
yeah,
it is.
it's out of 6 questions.
because in multiplication order.
Yeah, but you get 2 to be right.
It doesn't matter if ordered,
you can get 2 correct. Yeah, the probability you can
This is the probability of getting the first 2 correct and the next 4 wrong.
But it's also the probability.
So this is the probability of getting the first 2 correct and then being false on the next 4.
But the thing is,
But-
it's the same probability, so you just
Multiplication order doesn't matter.
It's also the probability of getting the first one right, the second one wrong, and the third one right, and then the rest wrong. But it's not the probability of getting either of these 2 cases. In order to do either of these 2 cases, we would need 2 lots of that, because there's 2 cases. So this is the probability of any one of these rows. How many of these rows can we make? We could get this one right, this one wrong, this one right.
6 factorial. That's because that's any possibility.
But surely the fact that it's 2 out of 6 will change it. We have to see 6 factors. Yeah,
Okay, are there more?
Yes.
What's unique about this one?
And the first one is always true.
So we have to have the first one wrong, and then the next 2 right. There will be less and less in each row. So we could get this one, and so on. How many combinations do we have in total?
36.
How many possibilities, how many choices do we have?
We have
6. And we want to pick 2 of the slots from 6. So we are choosing 2 slots from a total of 6 slots in order to put the T in. We've got 6 slots total. We're picking 2. We're filling 2 of those slots. So we use a combination number. We use 6C2. This is the different number of ways of choosing 2 from 6. That's what it means. You can use it for other things. Let's say we're doing a math competition and we've got 25 guys in the room and I need a team of 5. How many different teams could I make? That would be 25C5. I'm picking 5 kids out of a total of 25. And the order matters. So what we need to do to this in order to get the probability that we want is we need to times it by that. Because there's this many different ways of doing it. I think it's 15. Let's work it out. So let's try to work out 6C2. That is 6 factorial. No, let me do 6 times 5 times 4 factorial over 2 times 1 times 4 factorial. These cancel. This halves that one. We get 15. So the correct answer, let's work out the full answer. Our probability that x is equal to 2 is 15 times this, which is 15 times 1 over 16 times 81 over
64 times 4,
64, 256. Calculator at that point, and we get 0.29. 297 is it? 0.297. Did it this morning. I was recording when I got this.
I always felt
I looked at this, I didn't. I looked at
yeah,
I wish I was able to do this. All right. So let's improve our mathematical language on this one. So what we've got here is a binomial probability, and we have a format for that. So we have to start off by saying what x is. X is always the number of. X is the number of. What is x the number of?
Number of options.
The number of correct answers.
Isn't it just the number of total answers?
No, that's 6. X is the
Number of
x is the number of correct answers. How is x distributed? X is distributed binomially. We do 6 trials, and a probability of success is 1/4. This is the mathematical notation for this. Generalizing that, we've got x is binomially distributed NP. N equals the number of trials. P is the probability of success. We want the probability that the random variable x is equal to 2, and we calculated that to 0.297. So this is how we write it in a math question.
So what does this one mean?
It's distributed. And then the B stands for binomial.
It's only binomial if there's 2 options.
Yeah, it can only be a binomial distribution if it's either success or not success. And you have to have a set number of trials. You can't have you can't keep going until something happens. It has to be a set number of trials. Okay, have a go at this. Oh, so here is the basic theory for that. So we're using the binomial probability on this one. Here's the definition for you. I'll have a look at that later. Have a go at this last question. And we have still, even with a fire alarm, you have to finish this class in time.
It's easy. X is quick.
Whenever we finish this question, why do you have nothing to
It's
15 minutes of class now.
X is binomially, what's it called?
Binomially distributed.
That's binomial.
This is a binomial distribution.
So, okay. And so it's binomially distributed
And
and what is the combination?
That's how you do it, but not how you mathematically express it. Focus on how I'm writing it. Make sure your mathematical notation. That is not we do it in 15 minutes. When I teach something, don't keep learning it. You'll pay for it, like all the people who only did synthetic division, and then quickly divide by x minus root 2, x plus root 2 on the exam. You have to do polynomial division with x minus 2 squared.
You can have it converted to us and vote. Is that x equals root squared?
Yeah, root 2 is just a number.
Okay. Well, it's been like it's a rational benefit. So
It's like pi.
Just a number. Alright, let me go through this. I'm cutting it short a little bit so I've got time to hand out the tests to you guys. So let's go through this. What is x? X is, let me do this in blue. It's not a formula. X is the number of ... Then what is it? Boats traveling out to sea. Boats traveling down the river, approaching the mouth of the river, out to sea. Oh, it's out to sea. Out to sea. Okay. X is going to be binomially distributed because they either go into the harbor or they don't. They either go out to sea or they don't. So we want the probability that they're going to go out to sea. So how many trials are we having? We've got 5 boats. For each trial is 1 boat. We're going to see whether it goes into the harbor or it goes out to sea.
No, it's not. And it's 4. X is 4.
Oh, wait, what is the probability? Oh, wait. Oh, yeah. 1 in 5 is not what we want. That's the probability. We got 4 boats. Who said 5? What is the probability that a boat will bypass the harbor?
1 in 5.
1 in 5. We want the probability that x is equal to what? X is equal to 2. We want the probability that 2 of the boats. So we need 4C2. We need 2 out of the 4. 2 out of the 4. Our probability of success is 1 out of 5, and we want this to the 2. Our probability of not success is 4 out of 5, and this also has to be squared. And this is our answer. Let's find 4C2. 4C2 is going to be 4 times 3 times 2 factorial over 2 factorial times 2. These cancel, this cancels this, and gives us a 2. So this is 6. This is going to be 1 over 25. This is going to be 16 over 25. Okay, so 6 times 16 is going to be 96. 25 times 3 is 125. Times by 3 again, 625. Can we simplify this? No. We can see clearly here at this point that you can't simplify. Look back to the calculation. We've got 2 and a 3 here. So 6 is 2 times 3. There's no 2 or 3 in 25 or 25. This is 2 to the power of 4. There's no 5 in 2 to the power of 4. So this is just, we've got 5 to the power of 4 on the bottom. We've got 2 to the power of 4 on the top, and we've got 2 times 3 here. So there's no cancellation going to happen. So that won't cancel. So this is our answer. We are done there for today.